In this class, we are going to discuss about the concept of dependent source, supermesh, and supernode. Now, considering a network, the first network where we are having a independent source Vs and the dependent source as 3ix. 3ix, though it is plus and minus, this is a dependent voltage source, and it depends upon the magnitude of current, and this is a current dependent voltage source. Now the magnitude of this current depends upon this current Ix, which is flowing in the R3, and hence with either if R3 has changed or this Ix has changed, the magnitude of this voltage source will get changed. That is why this is known as a dependent source. Similarly, we can consider another network where we are having a dependent current source as well as voltage source. Here we are having three independent source, 5 volt, 9 volt and 7 volt. These are the independent source, whereas this source is a voltage source and having magnitude dependent upon Ix, and Ix is the current flowing in this branch. Similarly, this is a voltage, this is a current source whose magnitude depends upon Vx, and Vx is the voltage across 2 ohm resistance. If Ix and Vx varies, the magnitude of these two sources will also varies. That is why they are known as dependent source. Here we are having only one volt dependent voltage source, whereas in this network we are having one dependent voltage source and one dependent current source. In any network we can have any number of dependent source and any number of independent source, provided there should be one independent source is there. Now, considering the supermesh and supernode. Supermesh and supernode is a special case of analyzing in electrical system. A supermesh occurs when current source is contained between two essential meshes. Let's consider in this case, if there are two different meshes, and in these two meshes, instead of having a one resistance or voltage source, we are having a current source. To apply KVL in this loop, we can find out potential difference across R1, but we cannot find out potential difference Is, because the internal resistance of current source, ideal current source, is infinite, and hence internal resistance, unless we don't know what exact value of this source is, we cannot define what is the potential difference across this element. Therefore, to analyze this type of network, we have to consider this overall loop instead of considering two independent loops. Similarly, when we are having a voltage source connected between two nodes, then that concept is known as the super node. Here also we cannot apply KVL because we don't know the internal resistance of this source, and hence to find out the direction of the current flowing in this network cannot be defined. Similarly, in this branch also there is only a voltage source, and hence these are the special cases in electrical system that need to be analyzed in different way. If we can apply KCL in this network, we can apply KVL in this network. We can apply KVL in this network. Whereas while applying the KCL at this node, this is not possible because we are having a voltage source connected between two nodes. Unless the resistance of this path is not known to us, we cannot define the current in this circuit, and hence this is the concept of supernode. This is the concept of supermesh because we are unable to apply mesh equation. This is the concept of supernode because we are unable to apply nodal equations. Now, considering an example of voltage source, dependent voltage source. Here, let we are having a voltage source is in this circuit. This current is flowing here in this circuit. Let it is a dependent voltage source in this circuit. Let it is a dependent source in this circuit. This source can be analyzed as a voltage source. Here we consider this is a voltage source, this is plus, this is minus. Let there is some resistance, this is R1, this value is 2 ohm, this value is 4 ohm, its value is 3 ohm, this is 5 volt plus minus, and the magnitude of this current depends upon current in this branch, that is Ix. The voltage of this source is, let it is 2 of Ix. Ix is defined in this branch, and hence the current in magnitude of voltage is defined according to Ix. Now this is a network of dependent voltage source, we can apply KVL in this network. Applying KVL, this will be plus, this minus, this will be plus, this will be minus, this will be plus, this will be minus if the direction of current is taken this one. Now here it is, let it is I1, it is I2, this is I3, or if you are going to analyze applying loop analysis, mesh analysis, this will be I1, this will be I2. Instead of considering the individual branch, we can analyze this network. Now in the network where there is a dependent source, then it is not hard and fast that we have to solve this particular method. We can apply any of the method to solve these type of networks, until unless it is not mentioned by which method is to be solved. Now in this case, the KVL equation will be minus of 2I1, then minus of 3ix, and ix is I1 minus I2, then plus 5 is equal to 0. Ix is minus of 2 I1 minus of 3 I1 minus I2 plus 5 is equal to 0. Here we can say Ix is I1 minus I2 in this branch, and this is the first equation. Similarly, we can have second equation for second loop. It will be minus of, this is for loop 1, this is for loop 2. It will be minus of 4I2, then minus of higher, we are moving from higher to lower, it will be 2I of x, then we are moving from lower to higher, then it will be 3ix is equal to 0. Putting the value of ix in this equation, minus of 4 I2 minus of 2 I1 minus I2 minus of 3 I1 minus I2, and on simplifying these two equations, let this is the second equation, we are having two equations with two variables, then we can calculate I1 and I2 easily. This is the way we can solve a network having voltage dependent source. Similarly, a network, if the network is having a current dependent source, in this case, instead of having a voltage dependent source, let we consider we are having a network where there is a voltage, there is a current dependent source, and current dependent source here it is, let it is, instead of having a voltage source, let consider this is a current source. The same network, 5 ampere, 5 volt, this is plus minus, this is 2, this is 3 ohm, this is 2 ohm, this is 4 ohm, and the magnitude of this current, let it depends upon the current flowing voltage across this network, that is plus minus Vx. This is the voltage across this node, let it is 2 Vx. Now we can solve this network by applying, in this is for this loop, by applying nodal analysis as well as mesh analysis. To solve this network, it is better to go for nodal analysis because there is a one current source connected at this node. Let it is, this node is reference and this node is A, the voltage at this node is VA. Now since the current source is connected in this branch and the direction of current source is defined, then the current in this branch is already defined. Then let it is I1, this is I2, and in this case we can say that at this junction these two currents are entering at the junction, the third current I2 is leaving, then I2 will be equals to I1 plus I3, let it is I3, and I3 is equal to 2 of Vx. Now we can find out I1 will be equals to 5 minus Va upon 2, then I2, this is I1 is equal to, and I2 is equal to Va minus 0 upon 4. The I3 is already known to us, which is equals to 2Vx. Now 2Vx is nothing but I2 into May 4, which is equal to 4I2, and hence putting all these values in this equation, I2 is Va by 4 is equal to 5 minus Va by 2 plus I3, and I3 is 2Vx, which is equals to 2 is equal to 4 I2, and hence for I2. For I2, this value Vx is given by, and this value is just equivalent to Va. This is nothing but the voltage in this path. It is I is Vx. Vx is equal to Va, and hence we can say in this branch the current is I3 is I2, and by definition we know I2 is Va by 4, and hence Va by 4 is equal to 5 minus Va by 2 plus 4 into Va by 4. We are having one equation with one variable. We can find out Va, or here putting the value of Va in this equation, we can calculate I1 and I2 and I3. I1, I2 and I3. Here we need to apply only the concept. If we are knowing the concept, we can solve this problem. Now considering the super mesh, in case of super mesh, let's consider the network having a voltage source. If there is a current source in between, then this is the concept of super mesh. This is one mesh, this is another mesh. When we are going to apply voltage, this is 2 ohm, this is 3 ohm, let it is 4 ohm, it is 2 ampere, this is 4 volt. Now at this node, we cannot apply in this loop as a KVL directly, because there is a current source and we don't know what is the internal resistance of this current source is, and hence we have to go for this overall loop. Knowing the current in this branch is I1, the current here it is already defined, this is, and where the current in this branch is, let it is I2. And by at nodal analysis at Va, knowing the node at node A, this is applying KCL, it is I1 plus 2 is equal to I2. Now apply the KVL in this overall network. If current is flowing in this direction, this is plus, this is minus, this is plus, this is minus, this is plus, this is minus. This potential is already defined. It will be minus of 2I1 plus or minus of 3I2, then minus of 4I2, then moving from lower to higher, plus 4 is equal to 0. By the definition we know I2 is equal to I1 plus 2. Putting the value of I2 here in this equation, it will be minus of 2 I1 minus, putting 3 I1 plus 2, then minus 4 I1 plus 2 plus 4 is equal to 0. In this equation only I1 is the unknown quantity. We rearranging this equation, there is one variable and one equation, we can easily calculate I1. Knowing the I1, we can calculate I2, and similarly if we want to find out voltage across this 4 ohm resistance, that will be 4 into I2, that is equal to VR4. And the way we can solve the network if there is a super mesh. Now considering the concept of supernode, in case of supernode, let we consider we are having a network, another network, where there is a source connected between the two nodes. There is an element and one voltage source is connected between the two nodes. Let's consider this is, in this case, let a source is connected at this point. This is the concept of supernode, plus minus. There is node. This is R1, this is R2, this is R3. This is plus minus. Let it is 5 volt, it is 2 ohm, this is 3 ohm, this is 4 ohm. Now in this case we cannot apply nodal analysis at this node. Why? Because there is a voltage source connected directly with respect to reference, and hence the potential at this node is already defined. Then it can be solved by applying the concept of generalized equations. And generalized equation here means these two elements and in series the potential defined here, let it is 3 volt, which is applied across these two elements, and hence I into may r r2 is 3 plus 4 must equal to 3 volt, and hence I flowing in this circuit I will be equals to 3 divided by 7 ampere. We can calculate current in this branch. Now we can calculate current in this branch. This potential is 5 volt, this potential is 3 volt, va is 3, and hence I1, this current is I1, this current is I1 is 5 minus va divided by 2, and va is nothing but 3 volt. This is 5 minus 3 divided by 2 is equal to 2 by 2 is equal to 1 ampere. And hence in this way we can solve this network considering the concept of supernode, because we cannot apply directly as I1, I2, I3, and because we cannot find out I3 if current is considered in this branch, then the concept of nodal analysis is not valid. But if we can analyze this network in different way, then we can find out the value of current I1, I2, I, whatever the branch voltage we want to find out, accordingly we can calculate.